All right. So I don't know if I officially said it, but good morning. Hope all is well. Hope everybody's doing all right. Hope everything's going okay. So we're looking to close out chapter 10, looking at 10.2 today. I sent you guys a copy of this screenshot right here. Well, screenshot, but a copy of this hypothesis testing. We have the classical approach right here, p-value approach right here. So we'll look at those steps and everything. Initial conditions right here. And so let's look at a few problems in my math lab assignment. All right, so here, looking at number one, says when testing a hypothesis using the p-value approach, if the p-value is large, reject the null hypothesis. So basically, we'll go back to our p-value steps. Now notice right here it says if p-value is less than alpha. So if it's small, if it's less than alpha, you reject the null hypothesis. This is if the p-value is large, reject the null hypothesis. So that is a false statement. So according to our steps, it says if the p-value is small, you reject the null hypothesis. All right. Determine the critical value of the left tail. Okay, so here it says determine the critical value for the left tail test regarding the population proportion at alpha equal to 0.025 level of significance. So let's go to our z-score chart. Okay, there we go. So now at the bottom of your z-score chart, right down here, hypothesis testing, notice it says critical values. If it fit either one of these three, my eraser not working. My eraser not working. There we go. If it fit either one of these three normal significant level, whether it's 0.1, 0.05, or 0.01, then they will be right here. This one gives us 0.025, but I'm just showing you that if you see 0.1, 0.05, or 0.01, like you'll see in a few examples, those will be right here. You don't have to go searching for them. All right. But the one we just had was alpha at 0.025. So what we're going to do is we're going to have to go inside of, go inside of the chart and look for the closest value to 0.025. So 0.021, 22. All right, here you go right here. So 0.025 is right here. Sometimes it will be exact, sometimes it will just be close to it, depends on what numbers you get. But we see we have 0.025. So then we look at the corresponding z-score that matches it. So that's negative 1.96. Everybody okay with that?
Yeah, so far.
Mm-hmm.
Because even when I was looking, I was like, wait, how do I find it? Like, how do I find it? But okay, now I do it that way. Okay.
Mm-hmm. All right. So yeah, negative 1.96. So next question. All right, this is number 3. Okay, I did one like this in the notes. So let's go back to the notes. Wait, let's do this first. They give us your null hypothesis, your alternative hypothesis. N is the sample size. X is the characteristic and of your sample. And then you have significance level of 0.01. So the first thing they ask us to find is the p-value. Now the numbers on my notes are going to be different, but I was just showing you what they ask of you. All right. So this was my setup. Got 0.0. P is equal to 0.0. I keep saying 0.0. P is equal to 0.70. And then P is less than 0.70. as my hypothesis testing, null and alternative hypothesis. I have 150 for my sample, x is 95, and 0.01 for alpha. And so they asked for the p-value, so we're going to perform the test using the p-value approach. Now, if you go to your, and I'm going to flip back to it, but I just want to make sure we're clear. When you go to your steps, this part is already done. This part is already done. They already gave us our significance level. So now we need our test statistic. Notice that's p hat minus p naught over the square root of p naught times 1 minus p naught over n. So now p naught is always going to be this value here. So that's why we have that right here. P naught is equal to 0.7. P hat is always going to be x over n. So it's 95 over 150. And they gave me 0.6 with 3 repeated. So that's why I have to borrow the 3. So make sure we're okay with the establishment, what we was given, what our symbols represent. All right. Next, like I said, we need to find the test statistic, the Z naught. And so P hat, I went ahead and took that 3 out, 4 threes. Don't want to round it to 2 spots because remember your final answer is going to be rounded to 2 spots. While you're doing your calculation, you always want to round to 4 or 5 decimal places and then round your final answer to 2 decimal places to be as accurate as possible. So plug in the values here. And because I was doing the work on my iPhone, I did it in pieces. But if you have a legit calculator, you can always just put all this in just like that. Make sure you use parentheses where needed to include the whole numerator, whole denominator, that type of thing. So if you ever have questions about how to use your calculator, always, feel free to get with me. But once you put all of that in the calculator, that'll give you negative 1.78.
And the scientific calculator should be able to do that function, right? Because essentially then you're just dividing the top and the bottom to get the number. Okay.
Yep. I did it on my phone with the basic calculator that I had. Yep.
Okay, really? Okay, I was trying to do it last night. I was like, wait, how do I? Okay, so I'll try to do it that way.
Yep.
Okay.
All right. So then you go to your z-score chart, negative 1.78. Don't forget, I'll just show you this one more time. As a reminder as to how to use it. Look for negative 1.7 over here, 8 up here. So where they meet, negative 1.78. So that's where that value came from. Negative 1.78 gave us 0.0375, and that is our p-value. And the problems with the p-value. So remember that was the first thing they asked for. What was the p-value? Matter of fact, let me make sure on what they asked for of you next. And then they ask you, do you reject? Or what are you going to do? All right. So is everybody good on p-value before we go to the next step?
Yeah. So far, yeah.
All right. So now our conclusion is based on our steps here. So remember, it says if the p-value is less than alpha, you reject the null hypothesis. So you compare your p-value to alpha. Remember, alpha was 0.01. Yep, 0.01. Since the p-value is greater than alpha, we do not reject the null hypothesis. Once again, if it was less than alpha, we will reject the null hypothesis.
Okay, not too bad. It sounded bad when I was like, wait, hypothesis. Like, okay, so that's not too bad.
Yeah, it's not, as long as you
get the steps and
Yeah,
stuff.
follow the steps and, go use the charts. You should be fine. There's no real serious calculation. It's really about process.
Yeah,
Mm-hmm.
and the four decimal places. I was forgetting that. I was like, what? I made this wrong. And I was like, okay, 4 decimal places. Okay.
Mm-hmm. So let me show you. Was everybody good with that before I go to the next one? Make sure we're good. Don't want to go off the page if somebody still
Yeah.
copying. All right.
I don't know.
So, so before you copy number 4, let me show you what that problem would look like. All right. So here, test the hypothesis using p-value approach. Be sure to verify the requirements of the test. So notice it says is n times p naught times 1 minus p naught greater than or equal to 10. And so where does that come from? It's coming from your initial conditions up top. It says use steps 1 through 5, provided that, first of all, your sample is obtained by random sampling. Then this condition has to be the case as well. N times P naught times 1 minus P naught has to be greater than or equal to 10, which we've dealt with that initial condition before in the previous chapter. And then the sample values are independent of each other. So in other words, you picking your values have nothing to do with picking the next value and all that stuff like that. So that's where that came from. All right, so raise the point. I guess I'll leave that right there. So this was the initial set of information that they gave us. And this is what we want to establish. Remember that this is always your P naught. So we do 500 times 0.81 times 1 minus 0.81. And that gave me 76.95. And that will be the value that you plug in to the box. Where did you go? Right here. So that would be the value. You would say yes, and then put that value right here in this box. My number's a little different, so of course I wouldn't put it right in, but yeah. Now, if it was no, you would say, if it was less than 10, then you would say no, and then put that value right in the box. But all right. So the next thing they ask is for us to find the p hat. So that's going to be x over n. Basically, in this problem, they walk you through the steps and they ask you, for each piece. So the next piece is p hat. So you take 390, place it over 500, that gives you 0.78. All right. Next step, they ask for the Z naught. And that goes back to this formula right here, P hat minus P naught over the square root of P naught times 1 minus P naught over N. So you plug in your values accordingly. 0.78 is our P hat. We just found that. We already established that 0.81 was P naught. And N is 500. They gave us that. All right, so we should get negative 1.71. All right. So then we go to the chart and we get 0.0463 from the chart. All right, so now that's not our p-value because you always got to make sure you ask yourself what your test you're dealing with. So don't forget this is two-tailed because of the not equal to symbol. So if it's two-tailed, that means I need that 0.046 to be on both sides, two tails, all right? So notice what I say here in the purple. Two-tailed test, you multiply the p-value by 2. Now, if it was a left-tailed test, then we just took that value of right-tailed. Same thing, but we multiply the p-value by 2 for a two-tailed test. All right, let me see if they ask for anything else. Yeah, the p-value. Okay. Did I not write it? Oh, I didn't write it. Okay, so we got the p-value, and then from there you want to reject the null hypothesis or accept. So our p-value is 0.0872. Let's go back. What was our alpha? 0.1. Since this is less than the 0.1, we actually will reject the null hypothesis. So reason being is I have to make room for myself. P-value is less than alpha. All right, our alpha was 0.1. We have 0.087. For our p-value is less than alpha, so we will reject the null hypothesis. Any problems? Any problems?
Not yet, thank God.
All right, so let's look at what 6 is talking about. All right, so number 5, some have argued that throwing darts at stock pages to decide which companies to invest in could be a successful stock picking strategy. Suppose a researcher decides to test this theory and randomly choose 50 companies to invest in. After 1 year, 27 of the companies considered winners. That is, they outperformed other companies in the same investment class to assess whether the dart picking strategy resulted majority winners. The researcher tested his hypothesis to obtain a p-value of 0.285. Explain what this p-value means and write a conclusion. Researchers 0.1 or less. All right, so the p-value is 0.2 and the significance level is 0.1. That means you do not reject the null hypothesis. So let's see what we got going on here as our options. About 27 and 50 samples will give a sample proportion is, let me see, 27 as high or higher really is 0.5. So I need this one, need that one. 27 and 50. No, we're not rejecting 29 and 100. So where did 29 come from? Got it. It should be that one. Yep. All right. So I was looking at it wrong. So notice here it says 29 in 100 samples. That goes back to the type of problem that we had before. We take that 100 and multiply it to this p-value of 2858. You multiply that times 100. That's why it says about 29. So that's 100 times that p-value of 0.285. That will be 28.5, which is about 29. And then it says, will give a sample proportion as high or higher than the one obtained if the population really is 0.5. But notice once again, we could not reject the null hypothesis. So that means our null hypothesis says P is equal to 0.5. So that's why I say really is 0.5. So that's why I went with C. 29 times, well, 2858 times 100 gave me that about 29. And then it really is 0.5 because we're looking at the null hypothesis being true, not the alternative hypothesis, which says it's greater than 0.5. All right. And looking at the next one, p-value is 0.28. So first of all, we know it's not going to be A or C because it says because the p-value is small. We know that the p-value is large. So we're going to look at B or D. It says because the p-value is large, do not reject the null hypothesis. Remember, if it was small, we would reject the null hypothesis. So because the p-value is large, do not reject the null hypothesis. And then it says there is not sufficient evidence to conclude that a dart picking strategy is majority, in a majority of winners, that the dart picking strategy resulted in a majority of winners. So once again, that's holding true to your steps, but also trying to implement what's being said in the problem. All right, so before we go to 6, questions on what I did there. Couldn't write on this, so it would have been helpful. I could have wrote on it, but it's all good.
No, not so far. It's definitely, you just have to know the definitions for sure.
Yep, yeah, and trying to interpret it, yeah.
Right.
Okay, so let's look at 6. So a certain drug can be used to reduce acid produced by the body and heal damage in the esophagus due to acid reflux. The manufacturer of the drug claims that 92% of patients taking the drug are healed within 8 weeks. In clinical trials, 215 of 229 patients suffering from acid reflux disease were healed after 8 weeks. Test the manufacturer's claim at alpha 0.05 level of significance. Okay, so first thing we would do is notice it says they want you to test that we can either do hypothesis testing by doing n times p naught times 1 minus p naught. I believe all my numbers are different, but we still walk through the process. All right, let me go back. So they have 92, I had 94%. And so, but the test is still the same. It says manufacturer of the drug claims that more than 92%. So mine claimed that more than 94%. So more than means greater than. So that's why we have the greater than symbol, which also means it will be right-tailed. I write it down there somewhere. Hold on, I'm going back, y'all. I didn't write it up here, but more than also means right-tailed. All right. So as far as our null and our alternative hypothesis, questions on what I set up. All right. Remember, your null hypothesis will always be equal, and then your alternative hypothesis will be set up according to the keywords. Once again, the keyword here was more than. If it said less than, then we would have used the less than symbol. If it said different, then we would have used not equal to. All right. So I then had the phrase 214 of 225. If you go back to this one, it was 215 out of 229. But we're going off of mine, so but just showing you where it was in the problem. And so that 214 is the X. The 225 is your sample size, which is N. And that's what we needed right here. So N times 0.94, remember that's always your P naught. N times 0.94 times 1 minus 0.94 gave me 12.69. So before we go back to the problem, make sure we're good with what was said. What is done, I should say. All right, so let's go back to the problem. So because, let me go ahead and do this because I want to show you the wording. So we have 229 times 0.92 times 0.08. Now be careful here. Notice it says round to 1 decimal place. So that got me last class because I was trying to leave my 2 decimal places in there. This one ended up being 16.9. It's going to be greater than. The sample size is less than 5%. So we can assume the sample size is going to be less than 5% because we got 229 people. But we are talking about a whole population. So if you only have 229 as a sample size, you can assume that that's less than 5% of the population size. And then the sample can be reasonably assumed to be random. And that means that the requirements are satisfied. So I just want to show you the wording there. Questions on that sentence, make sure we're all right.
Yeah. So far. I like you showing the, like you did last semester where you go into the homework and kind of do examples this way. I don't know.
Yeah. I try not to cheat like that because that's cheating.
I know. I don't know. It was cool. So I'm glad you're doing the last one at least.
So when we go here, we already saw what we were going to do. I already wrote that out, but we would use P here for our parameter. And because if this talked about the mean, then we would have used our mean symbol. If it talked about standard deviation, we could have used standard deviation, but we were just talking about percentages, so we're using P here. And E equals, remember I told you it's always equal for H naught, and this was 0.92. In my notes, we're going back to the notes. Remember I had 0.94. I didn't mean to hit equal. And remember we said it was more than 0.92. And so that's that. So now let's go back to our notes, and we need our test statistic. Once again, I have different numbers than that one, but just walking you through the process. So don't forget we need P hat. P hat is X over N. That 214 of 225, the 214 is my X. 225 I already mentioned is my N, so 214 over 225 is 0.951111, so that one is being repeated. So that's why I just put the bar over the one. And now plug it into the formula. All right. That'll give us 0.70. All right, so now this one. All right, everybody done copying before I go back to the other screen.
Yeah, I'm okay.
All right. So here, and I'm just going to put in. I know it's not point. I'm just going to put in anything because we're trying to get to the next part of the problem. Huh? Not that far off. So now, notice this one asks us for our Z alpha. So that means that they're actually going to classical approach. So when you see that, for us, alpha was 0.1. And so what we can do is if we want to know Z alpha, we go to our other chart, our Z-score chart, and we come down here. If alpha is 0.1 and we have a right tail, then that means our Z alpha is going to be 1.28. All right, any problems with that? So that's where I got the 1.28 from. And I should have notated this was the classical approach. All right, so we're using the classical approach. It says for right-tailed, if your Z naught is greater than Z alpha, you reject the null hypothesis. So Z naught is less than Z alpha. And I didn't write, let me see if they actually asked for conclusion. Come on, man. Okay, yeah, they do ask us for the conclusion. So we are going to, so if you go, like I said, look at the steps. It says that if Z naught is greater than alpha, you reject the null hypothesis. Here we have Z naught less than alpha. So do not reject the null hypothesis. All right. Hold on 1 second.
So cute.
It is not.
I know. But I mean, I'm kind of used to it because last semester, it's just cute now at this point. I know it's cute. It's like work setting. I don't know.
Right. It's cute. It's cute to everybody but me. um, let's see. Do not reject null hypothesis. There is insufficient evidence to include. Yeah, so you would have chosen do not reject null hypothesis. There's insufficient evidence to conclude that more than 92. In other words, there's insufficient evidence to conclude that the alternative hypothesis works or is in effect. So let's see if that one automatically worked. Yep. All right. And 7, yep, 7 is just like that one. So pretty much walk you through 1 through 7 as far as your 12 problems are concerned. I don't even think I was sharing the screen. Yep, I wasn't. Yeah, I was talking about this problem. The result right here, do not reject null hypothesis. There's insufficient evidence to conclude that more than, for us, it would have been 94% of the patients taking the drug are healed within 8 weeks. But then I was showing you that number 7 is exactly the same. So, yep. So that's about 7 of your problems. Got 5 more to do. So, you should be able to take that, as your foundation and go after those few problems. Questions on anything we've done so far? Everybody good?
Yeah, I'm just tripping because I can't believe we only have like a week left. So.
Yeah, man. Yeah, it's almost over.
Yeah.
So what I have to
Thank
do
God
for
I'm
you
not
guys.
behind though. Like, you know what I mean? Thank God. But I'm just saying still.
Oh yeah, I think the break, the break will be needed and necessary for everybody.
Right.
Yeah, but so what I got to do for you guys is actually create the test review and post that, for the final test and post that for you guys and go from there. So before we close out today, any questions or concerns, comments? All right.
I don't think so, no.
All right. So try the stuff out. Next week is all about reviewing. You guys asking whatever questions you want to ask. And then I sent you that email with information on the date of our final exam and how we're gonna handle it. Make sure you read that, check that out, and if you have any individual questions, make sure you shoot me an email on that. And then yeah, all we're doing now is closing out our assignments. Remember, you have until May 9th for anything that's in my math lab to get done, and get ready for this final.
Last night I did chapter 10 definitions just because I didn't know. So I kind of just did that and made it like assignment 5 and sent it to you just because I'm tripping now because it's like we're almost done. So I'm like, yo, we just give this to him just because. I don't know. So like,
Yeah, I didn't make it mandatory, but I can still use it as extra credit or something like that. Yeah.
Okay, I'm cool with that too. Okay, cool. All right. Well, yeah, that was it for me, but I hope y'all have a good day.
All right. Thanks. You have a good one as well.
Thank you.
All right. Everybody else have a good one. Take care. And I will see you next class.
All right, guys. Take care.
Bye.
All right.
Very much.
Thank you. Have a good one.
You too.